All right, we're going to start with grading Chapter 7 review. You definitely want to know all of these definitions for the test. All right, a chemical bond is a force that holds two atoms together. Ionic bond is a force that holds oppositely charged particles together. Monatomic is only one atom. Polyatomic, more than one. Formula unit shows the simplest ratio of ions in an ionic compound. Coordination number is the number of ions of opposite charge that surround each ion in a crystal. And you definitely want to know that a crystalline structure is one in which the cation is surrounded by an anion. And the lattice energy is the energy needed to separate electrons from an ionic compound. I would definitely know at least 3 of these properties for ionic compounds. They're crystalline solids with high melting points. They're brittle, highly water soluble. They will not conduct as a solid, but they will as a liquid or aqueous, which means dissolved in water. Subscripts in a formula mean how many atoms there are of that element. So BaCl2 has one Ba and 2 Cls. You definitely need to know how to do this type of problem here in number 10. You tell me what element it is. This is manganese, only one, because one is understood. Oxygen 2. Chromium, 2 atoms. Carbon 2. Oxygen 12, because you have to distribute the 3 into what's in the parentheses. Same thing here. So aluminum is just 1 atom. Oxygen 3. Hydrogen 3. Barium is a metal that's going to lose 2 electrons, so it forms Ba2+. Nitrogen is a nonmetal. It's going to gain 3, so it's N3-. S2-, if I'm drawing the electron dot structure, remember you can put brackets around it, but anions have charge and all 8 dots. Cations have a charge and no dots. And then remember, when it comes to the neutral atoms, all you have to do is look at the periodic table. And when you're on the periodic table, right, you look at how many valence electrons there are. So here's phosphorus, 5. And then you draw the 5 dots. Moving on to page 2, you definitely have to know how to show electron transfer. Here, calcium has 2 dots. I has 7 and 7. You show that the metal is transferring with arrows. Over here, the cation, no dots, right? And then the anions, all 8 dots with the charge here too. We know that electrons are being transferred. The overall charge is 0. 2 plus, 1 minus, 1 minus gives us 0. An ionic compound will conduct in the liquid state or dissolved in water, but not as a solid, okay? Why? Because there's free-floating ions when it's a liquid or dissolved in water. This will not form because it's 2 metals. This one will. This one will not form because Ba is 2+. This one will not form because Mg is 2+. 17 reinforces that metals, there are some metals that have more than one charge, and we have to specify the charge of that metal by using parentheses. So it's important that you know how to figure it out by looking at the anion. So if I know that F is 1-, right, Cr is F2 here. If F is 1- here, Cr is 3+. You also have to know how to do a problem like 18. There was an example here. NO3 is 1-, right? So tungsten, if you look at your periodic table, there's multiple charges that tungsten can be. It's 6+, because in order for us to get this formula, it has to be a 6+. So here's Cr2+, Pb4+, Na1+, Ti3+, Mn6+. Moving on to the next page, I'm just going to go ahead and give you time to check these. So go ahead and look at 1 through 7. I would definitely know how to do this one here, number 4, because you have to reduce. Okay, moving on to the next section, we're going to look at 8 through 14. This one here, don't forget the parentheses around the OH. If you need more time, you can stop the video. Okay, now we said that when it comes to names, it's a little bit more of a challenge because some of them need Roman numerals. So if we're looking at 15 to 21, notice how this one has a Roman numeral, and the reason why is because iron can be 2+ or 3+. And then we're moving on to 22 to 28. Careful with 26. And the other thing is, don't confuse magnesium with manganese. A lot of students do that. Here's another one that you should know for the test. Okay? If you need more time, please pause the video. Then on the next page, looking at 1 through 10, you don't have to write out the ions, but not writing out the ions is just assuming that you're doing a lot in your head, and that's where you're going to start making mistakes. So please try to minimize doing so much in your head. I would definitely know how to do one like this. So that's 1 through 10. Moving on to 11 through 20. Another one where you have to use parentheses. This one too. All right, moving on to 21 to 30. Once again, some of them need Roman numerals because the metal has more than one charge. All right, 31 to 40. Once again, if you need more time, go ahead and pause the video. All right, now what we're going to do is look at our new set of notes, which are the nomenclature notes. When it comes to the nomenclature notes, what we are doing is learning how to write 5 different types of names and formulas. And 2 of them are very easy because they just come from the periodic table. So the first thing we have to be able to do is identify the type. Does it have more than one capital letter? If it's yes, it's a compound. If no, it's an element. So let's do that first. So NaCl, more than one capital letter, compound. HBr, more than one capital letter, compound. Compound, right? 4 is an element, only one capital letter. Compound, compound, element, compound, element, because it's only one capital letter. 10 is a compound. 11, element, only one capital letter. Compound, compound, element, only one capital letter. AlOH3, compound, compound, more than one capital letter. Now what we're going to do is decide, right, if the element is an atom or a diatomic. Diatomic, there's 7 of them. H2, and then the other 6 come from the elbow. N2, O2, F2, Cl2, Br2, I2. So if it's one of these, it's a diatomic. These are elements that travel in pairs. If it's not one of these, then it's an atom. So I'm going to look and see, right, if I have any that are diatomics. That are, well, first of all, they have to be elements, right? So element, H2, yes. So this is a diatomic. Au, no. So it's an atom. CO is not one of my 7, atom. N2 is one of my 7, so that's a diatomic. Down here, not one of my 7, atom. Okay, now we have to look at, is it ionic, a molecule, or an acid? So we're going to start with ionic because that is what we are familiar with. The ionic compound is the one that starts with a metal or NH4+. All right, so we're going to look at the one that's compound, right? But it has to start with the metal or NH4+. NaCl is a metal, starts with Na, left side of the periodic table, ionic compound. The next compound, H, not a metal. It is on the left side, but it's not a metal, right? This one here, compound, starts with NH4+, so that is an ionic compound. Next one here, not a metal, so it's not an ionic compound. Not a metal, not a metal, it's not a compound. Here, BaO, Ba is a metal, that's an ionic compound. NaF, N is a metal, so that is an ionic compound. CH4, not a metal. Down here, compound, compound, Al is a metal, ionic compound. This one doesn't start with a metal. So now the next thing is, if it's all nonmetals, it's going to be a molecule. But here, we're looking for acids. Formula starts with the letter H and is H2O. If it's H2O, we're going to name it as a molecule. So the only exception, right, that it starts with an H and it's H2O, it's a molecule. Everything else that starts with an H is an acid, okay? So let's do our molecules next. So it has to be a compound first, right? I can see that this is HBr. That starts with an H, so that's an acid. So I'm just going to go ahead actually and do them at the same time. So A is an acid for HBr. The next one we have to do is NO2. It doesn't start with an H, so it is a molecule. C6H12O6 doesn't start with an H, molecule. That one's done. CO doesn't start with an H, molecule. Next one we have to do is 13. 13 doesn't start with an H, molecule. And then the next one down here, HNO3, starts with an H, so it's an acid. So that's all 16. I'm going to go ahead and give you some time to make sure that yours are correct. So there's 1 through 11, and now 12 through 16. Okay, moving on to page 2. So we already know the element, there's 2 types, right? There's 2 types. We know that they are the atom, and we also have the diatomic. Identification is that it only contains one atom, right? One capital letter. No subscripts, okay? So like if I have AU, I just look at the periodic table, and when I look at the periodic table, the name of AU is just gold. And so I write the name of that by looking at the periodic table. So here if I have AU, right, gold. Here, one capital letter, no subscript 2, Mg, over here, magnesium. Now when it comes to the diatomics, 2 atom molecules of 1 element. Here are all of them. Remember there's 7 of them. H2, O2, N2, F2, Cl2, Br2, I2. If I sound this out, it sounds like Han-Fickelbrei, so you can kind of remember that. This Han-Fickelbrei to remember your 7. The other thing is they all end in GEN or INE. So what does that mean, right? Hydrogen, example, right, ends in GEN. Fluorine ends in INE. So all 7 of them end in GEN or INE. You name them the same as the element. So H2 is just hydrogen. And O2 is just oxygen. So you just look at the periodic table. We're going to get rid of this line. So now we know, based on the last chapter, there's 2 main types of bonding, all right? Ionic, which we learned in the last chapter, And now we're learning covalent, which is molecular bonding. So what does covalent mean? Co means together. Valent means the electrons in the outermost shell. So they're the ones that are on the outside. So we're sharing the electrons in the outermost shell. The elements are sharing. Covalent bonding occurs because the atoms in the bond, right, or in the compound have a similar tendency for electrons. And that means that they're going to gain electrons. This is going to happen when two or more nonmetals bond together. So here, sharing of electrons, F2. This F over here has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. This one over here also has 7. 1, 2, 3, 4, 5, 6, 7. So what can happen is they can share between these two, and then now this one has 1, 2, 3, 4, 5, 6, 7, 8. That's happy. 1, 2, 3, 4, 5, 6, 7, 8, and that's happy. So because electrons are shared in covalent molecules, there's no full ionic charge. So we get to forget about charges, and there's no reduced crisscrossing in these problems. Now we're going to move on to the next page, and we're going to look at properties of ionic compounds. So the smallest representative unit of an ionic compound, okay, is going to be a formula unit. For covalent, it's a molecule. We already know that when it comes to an ionic compound, it's a complete transfer of electrons. And then over here, it's a sharing of electrons. Ionic compound is cation plus anion, metal plus nonmetal, right? Or starts with NH4 plus. And then covalent is 2 or more nonmetals together. Here are some good examples, right, of the two. Physical state at room temperature, solid, liquid, or gas. Ionic compounds, we learned from the last chapter, have high melting and boiling points. And for molecules, they're low. When it comes to solubility, so do they dissolve in water? Like salt does dissolve in water. Molecule, you have the range of high to low. We know that ionic compounds can conduct as a liquid or dissolved in water, but molecules are poor conductors. All right, so now we move on to looking at our concrete examples. All right, so we already know about ionic compounds. And we said that our concrete example of an ionic compound is sodium chloride. So that's still going to be the same. But we have to add 2 more to our bank of concrete examples. The first one that we have to add is NH4Cl. This is ammonium chloride. And this one is iron 2 chloride. So why did we add 2 more? We added this one, right, because it's made up technically of all nonmetals. And I don't want you to think of it as a molecule, because you have to recognize that this is ammonium, okay? Why did we add this one to our concrete examples? Because sometimes, right, we have to put the Roman numeral. If the metal has more than one charge, we have to put a Roman numeral. So these are our 3 concrete examples that we want to have when we think about ionic compounds. Now on the right side, we're going to look at molecules. So this is what's new. All right, but a lot of you already know what CO2 is. CO2 is carbon dioxide. You may also know that CO is carbon monoxide. And H2O is water, but that's not the actual molecular name. The molecular name, there's 2 H's, so we call that dihydrogen monoxide. Okay? So now we are going to look at formal notes on how to write molecule names and formulas. When it comes to covalent molecules, remember it contains 2 or more types of nonmetals. The key is to forget. Forget about charges because there are no charges in molecules. We're going to use the Greek prefixes to indicate how many there are. So we need to know those Greek prefixes. 1 is mono, 2 is di, not bi, okay, because these are the Greek prefixes. 3 is tri, 4 is tetra, right? Think of Tetris. In the game of Tetris, you have all pieces that have 4 squares together, not quad, okay? 5 is penta, 6 is hexa, 7 is hepta, not septa, 8 is octa, 9 is nona, 10 is deca, okay? The next thing we have to know about naming molecules is we do not use mono on the first element. So let's see if that's true, right? This is one, understood, right? No mono on the first element. We don't say mono carbon dioxide. We don't say monocarbon monoxide. So it's only on the first element, right? So this is the first element, this is the second element, okay? Ending of the second element changes to IDE. Only the second element changes to IDE. We don't say carbide dioxide. We say carbon dioxide. You only change the ending of the second element, okay? They normally do not have double vowels, but this is kind of tricky because it only applies to AO and OO. So specifically, if the prefix ends in A or O and I combine it with oxide, I have to drop the vowel from the end of the prefix. So now we're going to look at examples. So here, 1 is understood after this carbon, after this Cl, after this H, right? When it comes to the second element, 1 is understood here, 1 is understood here. Now, we wouldn't normally do that, but these are formal notes, so we want to make sure that we do this correctly. So 1, the prefix is mono, but remember, we never put mono on the first element. So it's just going to be carbon, and the name of the first element does not change on the ending for the first one. 4 is tetra. Chlorine, right? But we have to change chlorine to chloride. And it's carbon tetrachloride. The next one, H2S, right? Prefix for 2 is di. H is hydrogen. Remember, the ending of the first element does not change for the ending, so dihydrogen. S, there's 1. Remember, we do put mono on the second element if it's just 1. Sulfur changes to sulfide. Cl1F3, once again, 1 is mono, but we don't put mono on the first element, so it's just chlorine. 3 is trifluoride. H1Cl1 is going to be, we don't put mono on the first one, so hydrogen. 1 is mono. Chlorine changes to chloride. Okay? Now for the name, it's extra easy because all I have to do is interpret the prefixes. Hydrogen monobromide, right? So there's 1 H, 1 Br, so it's just HBr. 2 for di, tetra is 4. Nitrogen, N2, F4. Now, we don't reduce, ever. We never reduce on molecules because these aren't charges, right? We simply write what the formula is. Xe is xenon, 1, 3 for fluoride, so it's F3. Phosphorus 1, triiodide, iodine 3. Notice how that does have 2 vowels there. It only applies to the AO and OO, okay? So here we have phosphorus triiodide, okay? So now we are going to fill in our last page because we want to make sure we understand this page here. So, one capital letter, atom or diatomic, right? We already learned that today. Molecule, we learned today too. And then ionic compound, that's something that we learned at the very beginning, so we're going to start with that. And that's going to be IC. Identification, we're going to say that it's metal plus non-metal, right? Or starts with NH4 plus. Okay? You can also say that it's a cation plus anion. The name, right, is we're going to name the ions, but, right, we might need metals with more than one charge need Roman numeral, right? For the formula, we find the ions, reduce, and then crisscross. Our concrete examples, right? NaCl, sodium chloride. The next one is FeCl2, which is iron 2 chloride. And then the last one is NH4Cl, which we have to recognize is that positive ion, ammonium chloride. So that's what we learned last chapter, and now we should know how to name those completely. The next thing we looked at are atoms and diatomics, right? One capital letter, no subscript for these, right? The name is we use a periodic table. The formula, we use a periodic table. Example, boron, right, is just, actually we'll put boron is B, okay? And then our diatomics, right, identification, H2, O2, N2, F2, Cl2, Br2, I2, Han-Fickelbrei, right? It's going to be one capital letter with subscript 2. The name, right? We use the periodic table. Name ends in GEN or INE, right? The formula, right, is H2O2 N2 Fickelbrei, right, F2 Cl2 Br2 I2. Example, O2 is oxygen. Now for the molecule, right, 2 or more nonmetals, NM means nonmetal, right? The name, we're going to use prefixes. So we have 1, 2, 3, 4, 5, mono, di, tri, tetra, penta. 6, 7, 8, 9, 10, hexa, hepta, octa, nona, deca. Formula, right? We use prefixes. Examples, right? We said our first example was CO2, carbon dioxide. Our second example, CO, carbon monoxide. And then the last one, H2O, dihydrogen monoxide. Okay, so that completes our notes. But now we're going to look at the homework. The homework is to do N1, which is this page here, and the back here. I have found that students really struggle with names here. Remember, you only put mono for the second element, not the first element, so don't forget to put it on the second element if there's only one. So that would be a hint for like number 3. Okay, and this completes our video.